Yeah, I'm glad I could help. That's a very good teacher on you.
Okay, silence again. Hey, quiet. Look, they show you f prime. So this is a graph of f prime. Which of the following describes all relative extrema of f? Stop right there. Okay, the minute you read the words relative extrema, your brain has to immediately think that means relative mins and or relative maxes. Okay? Or correctly stated, relative minima or relative maxima. I like the word mins and maxes better, though. It's not really a word. Never mind, I'll stop talking. Okay. You good? So now you have to remember the definition. It's on your white, sheet protected reference. Any function has a relative min or a relative max when that function changes, increase to decrease, or vice versa. So I'm looking here. That's what will cause f to have a relative min and or relative max. Questions on that? There's like 6 problems on the test that test this idea. Okay. But I'm looking at f prime. So I can't look for that. I have to look for something different on f prime. I look here. When f prime has y coordinates that change from positive to negative or the other way around, that's where f will have this type of change. So I look here, one second, I'm sorry. So I look here and I note negative, 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 positive. I'm paying attention to the sign of the y coordinate of this graph of f prime. Okay? Make sense of this, if not raise your hand. Right here, f prime has a relative max. F prime, not f. F has a relative max at this x coordinate. Because that's, oh, my bad, this one. Because that's where f prime is changing from positive y values to positive y values to negative y values. Okay? Yeah. Look, Abby, please.
Is relative min and relative max the same thing as local max?
Yes. 2 points. Right?
If it showed f double prime and we were looking for the max and min for f, instead of looking at positive and negative, should we look at like where the graph starts to increase and starts to decrease?
2 points. Don't miss this. It showed up in a question on the test. Hey, right here. If you're looking at f double prime, look what's here. Look at the big blank spot. Come on, look at it. If you're looking at f double prime and trying to figure out when f changes from increase to decrease, it's not possible. You can. That's it. Just does. There's no connection.
Well, no, I mean like on the f double prime graph.
Right. If you're looking at f double prime, you can look at the f double prime graph all you want, but there's not a tight connection between what f double prime is doing versus when f increases or decreases. So you can't find the connection. That's why this is blank. Please.
Just the way I did it, I don't know if it's like right, but I got the right answer. It's just I looked at on the f prime, I did like when it was increasing or decreasing, just like the concavity, because if it's concave up, then that means like a min. So that's how I did it. Is that like bad to do it that way, or?
Gotcha. And this might be related to what Ryan is asking, I'm not sure. Everybody, look, 2 for Sydney. Don't ever, ever, ever try to find a relative max on F by paying attention to the concavity. It really will sometimes work, sometimes not. So it's not reliable, so don't do it. Like it worked on this one, but it will not always work. Is that okay? Anybody else? Please.
When we're done with this one, can we go for number 10?
10, yes. Here's why, Sydney, look. Here's a graph that is concave down, then concave up, then concave down, and that graph has no mins or maxes. So it's not reliable. Is that okay? Please.
So can you say when f prime changes from positive to negative, that's always going to be a relative max on f?
Yes. And if you, no, it's perfect. Listen, and that's just referencing another thing to help you remember, okay? So on that sheet I gave you, that's precisely what I wrote. Let me just find it real quick. Right here, Lauren. Let's copy it and move it. Hold on. Come on, open up a page. Paste, there we go. Okay, look right here, Lauren. Any function. So what you just said was f, which is fine. So f has a relative or local max when f changes increase to decrease, or when that function's derivative, f prime, changes positive to negative. Is that not what you said?
Yeah.
Perfect.
Thank you.
10? Eva? All right, here we go. Look. First question says, does the limit as x approaches a exist? So your flashcard memory springs to life and says, oh yeah, when I'm finding a limit, check to see if x approaches infinity. No. Second thing, oh yeah, factor. Whoops. That one. So f of x equals questions to them.
Well, I just have a question, because I did this kind of differently, but I'm not sure if it was correct. I got the right answer, but when I looked, I remembered that for a limit, the left and right limits have to be the same. And since the top one is saying x is not equal to a, so it's anything that is besides a, so it could be a number that's super close to a, then wouldn't it exist because both the left and the right have the exact same equation?
Gotcha.
Does that make sense?
Yes. It's not 100% true that just because the equation is the same, that the left and right limits will match. It is highly, highly probable.
Yeah.
I can't say 100%, but it's very likely. So the logic is good. What you said, like everything you said is good logic. One other caution. Later in the problem, they're going to ask us if the function is continuous. So to know that, you don't know that yet, but to know that I'm going to have to find out the value of the limit. Like I have to know more than does the limit exist.
You have to find out if it's equal to 0.
Right, exactly. So I have to know what that limit's value is. So the factoring is going to be needed at some point.
Yeah.
But your logic is good.
So I think, yeah, I was kind of caught like a lucky break because it's not equal to 0, so then it's not continuous. But if it was equal to 0.
Correct.
Okay.
Does that make sense?
Yeah, that does.
Please, Christina.
What if A was equal to something like super close to 0, then could it be continuous?
It would, and well, it'd have to be infinitesimally close. So there's no way to write down a value of A that's that close per se. The problem is kind of flawed in that sense. Like they tell you A cannot be exactly 0 because then the function does become continuous for sure. For the purposes of this discussion, just assume A is enough difference. So. Okay, are we good to hear? Go ahead.
So when you broke up x squared minus a squared, and anytime you like break up a phrase like that,
Whatever expression.
an expression like that, does it have to have like a minus and a plus?
Yes.
For like the signs?
Now, memorize this, everybody. Okay, something minus something. Something minus something will always factor into square root of the first minus square root of the second, same thing plus. That's what you're saying, right? That this minus this always factors into x minus a, x plus a.
Yeah.
Yeah.
Okay, just wanted to get it.
If this says x plus, hey, warning, if this says x squared plus a squared, it only factors with complex values, which we're not studying in this class. So don't factor x squared plus a squared. You good? Everybody else good to hear? Okay. Must memorize what this means right here. That's only equal to one of two things. Undefined and 1. No other choices. What must x be for this to be undefined? Louder? A. But you don't use x equal a. Lauren explained that. So it doesn't apply to this. So in this problem, that's only 1. It is nothing else. It's just 1. So the f function is really this. Questions? Cool. So does the limit exist? It's what Lauren said. When x is close to a, what's the y coordinate? 2a. When x is almost a, you'd put in a number here that's almost a. You'd add it to another a, you'd be very close to 2a. So the limit, as x approaches a, of this function is specifically 2 multiplied by a. This is a true statement. The value of the limit is 2a. Questions?
So you just took that and did like a plus a because you're approaching a, right? And you plugged that
Right.
in for the
I
x.
really did something slightly different in my head.
Okay.
In my head, what I did was close to a added to a would be what? Close to 2a. You comfortable with that? Think of it as a number. Think of it as 5. What's close to 5 added to 5? Close to 10.
Yeah, close to
Fair?
Yeah.
So, but that's just 2 times 5.
Oh, okay.
You see it better now.
Oh, yeah, that makes sense.
Is that better? Good. Let's go here.
Could you push 13 after this?
Yeah.
So basically those two equations tell us that there's a removable. So then 3 would just be 4.
The limit from the left and the right are 2a. The value of the function at a is exactly 0. So this is also a true statement. But because these two are different, the function is not continuous. It's a removable discontinuity.
But if it wasn't saying copy equals A, then it would pretty much, it would be continuous, it would be just 2 times 0, because A is equal to 0.
Oh, if a is equal to 0, then this becomes a true statement. Yeah. 13?
Yeah.
There's the work. The steps are numbered. Ask about any step. I'll just wait for questions on this one. This is 13. Please, Edie.
So I can see it up to like step number, or not step, but like number 3.
Right here.
That part. Actually, no, even to the next one, but I just don't get how it's 4 easier.
So this is really dumb. My neighbor. So 4 and 5 are the same step. Sorry about that. Ignore that. It makes no sense. Okay. Are you okay from here to here?
Yeah.
Totally comfortable from here to here. Good. You're right? Okay. So what I'm going to do here is what I talked to Maya earlier about. I'm going to check left and right. So I'm going to put in place of x a value that's a little more than a and a little less than a. You with me? So let's do that over here. It makes it easier to see. And what I did with Abby a second ago seems also helpful. Let's just do a number for a minute. So let's put in 5. So I choose close to 5 squared plus, that means I'm choosing a to be 5. You understand? 5 squared. Well, what would this be really close to, Ian?
Right?
Yeah, 50. It's 5, but that's the same thing. Listen, it's what I said to Abby. That's the same thing as 2 multiplied by 5 squared. So this is really, if you need to leave, you can. I'll just keep talking. This is 2 multiplied by 5 squared.